everybody, in this video I'm going to go over some constant velocity problems. These are problems that we didn't get to in class, and we're going to go over a couple. This is optional, you do not need to watch this video, but if you're struggling with doing some of these practice problems, you might want to give it a watch. Okay, so in this first problem, I'm given a graph of position time, and I'm asked three questions. I want to find the velocity, I want to write an equation for the motion of the object, and I will find at what time the object will reach a position of 85 meters. So let's start from the beginning. To find the velocity, I know this is going to be the slope of a position time graph. Okay, and how we find the slope is we take 2 points. I'm going to just work up here, and we're going to do the second position minus the first position over the second time minus the first time. And I want you to notice that these x's, they stand for position. That is not the x variable. I know that that's confusing, but unfortunately, that is the variable that all physicists use. And t stands for time. Okay? So I'm going to pick 2 points. You can pick any 2 points you want. Let's pick this one and this one. All right, so our first one we see has 1 second and 10 meters as our position and time. This one here has 3 seconds and 30 meters. And we're just going to plug this directly into that slope equation. So here, this is our time 1, this is our position 1. This is our time 2, this is our position 2. We want to make sure time 2 is at a later time than time 1. So now let's plug in. So x2 is 30 meters minus x1 is 10 meters divided by time 2 is 3 seconds minus time 1 is 1 second. Okay? And now I just calculate. So 30 minus 10 is 20 meters. 3 minus 1 is 2 seconds. And 20 divided by 2, I'm going to do below, is 10. Our unit is meters per second. And this here is our velocity. Okay, our velocity is our slope of our position time graph. So here we have our first answer to our question. Velocity is 10 meters per second. All right, so now we're asked to write an equation for the motion of an object. I'm going to move down here for this. So we know our general equation is always x equals vt plus x naught. In this, x is position, v is velocity, t is time, and x naught is starting position. So we know what the velocity is because that's what we just calculated. And we have to find what is the starting position as well. So we look at our graph, and the starting position is the position at time 0. So in this case, our position at time 0, x equals 0 when time equals 0. It's also possible you could have a graph that looks like this, and then your position would be 20 for your starting position, but in this case it is 0. Okay, so now let's plug into this equation here. And so we get our specific equation, which is x equals, plug in our velocity, which is 10, t plus plug in our starting position, which is 0. And this is our answer to number 2. Okay, this is our equation for the motion of the object. And now we can use this equation to answer number 3. Number 3 asks, at what time will the object reach a position of 85 meters? Okay, so for number 3, let's pick a new color. We're saying a position is 85 meters, and our time we want to know. So we're going to plug this directly into this equation that we just made. Oops. Okay. We're going to plug in that x into the x in the equation we just made. And we're going to say 85 equals 10t plus 0. Okay. The 0 kind of just goes away. And so we have 85 equals 10t. And so we want to get t by itself, so we're going to divide by 10. And we get t equals 85 divided by 10, which is 8.5, and our units for time is seconds. And this is our final answer. So what we did was we looked at our graph, and we found the slope to find the velocity. Then we plugged into our general equation, replacing the velocity with the velocity we calculated and the starting position with the starting position from the graph. And that gave us a specific equation. Then for number 3, we plugged in the position we were given and solved for t into that specific equation. And that's how you would solve a problem involving a graph. Now let's solve a problem that doesn't involve a graph. We have a basketball is moving to the left at a constant speed of 1.5 meters per second. A tennis ball is moving to the right with a constant speed of 2 meters per second. And when you start observing them, they're 8 meters apart. At what time and position will they meet? Okay, so this is one of those two objects meeting situations. And in these situations, I like to start by drawing a sketch. So this is my basketball, and this is my tennis ball. Okay. And we have to remember that we need to pick a positive and a negative direction. Okay, you could pick either way. I usually put positive to the right. The basketball is moving to the left. So, I just drew this backwards because this basketball will be moving to the right. So let's fix that. This is our basketball. It's moving to the left. This is our tennis ball. It's moving to the right. Okay, so the basketball is moving to the left, which is our negative direction. So we're going to say our velocity is negative 1.5 meters per second. The reason I made it negative is because I said the left is going to be negative. Okay, and the tennis ball is moving with a velocity of 2 meters per second. I'm going to keep that positive because it's moving to the right, which we said is positive. And now we need a position, okay? We know that they are 8 meters apart. So what that means is we can set either one of them as 0 and the other one as 8. I'm going to set the tennis ball as 0 and the basketball as 8 meters. And these will be our starting positions. Okay? So the reason we can do this is because you can set your 0 point wherever you want. The only thing is if I put my 0 here, then this would have to be negative 8. Okay? Because of where I put my positives and negatives. All right. So now we have the velocity and starting position of both of these objects. So we're going to make an equation. Remember, our general equation is x equals vt plus x naught, but I'm going to plug in for my v and my starting position. So I get x equals 2t plus 0. Okay? And I just got rid of the units. I'm going to put them back in the end. Then for my basketball, I have, again, x equals vt plus x0, and I get x equals negative 1.5 t plus 8. So I want to find where they're meeting. So what we're going to do is we're going to set them equal to each other. So I'm going to say this position has to be the same at this position when they meet. So I have to set them equal. So I'm going to say 2t plus 0 equals negative 1.5t plus 8, and I'm going to solve for t. So I want to get the t's on one side, so I'm going to add 1.5t on both sides. So that gives me, combining like terms, I get 3.5t, that's 0, I'm going to just not write it, equals 8. I still need to get t by itself, so I divide by 3.5 and put that in a calculator. 8 divided by 3.5, and I get time equals 2.28, okay? And our unit for time is seconds. So that's the answer to this first question. At what time will they meet? The answer is 2.28 seconds. But now we want to figure out the position. So to do that, we need to plug that time into either one of these equations that we wrote. So we can plug it in, this time in here, or we could plug it in here. Both of them will give you the same answer. So let's do the one on the left. So I get x equals 2 times 2.28 plus 0. Put that in a calculator. And I get 4.56. And the units for position is going to be meters. Okay, let's show that it would be the same. So here, using this equation, I'm going to say x equals negative 1.5 times 2.28 plus 8. Put this in a calculator. And I get x equals 4.58. Now you might be saying to yourself, these are not exactly the same number, but they are very similar, right? They both round to be equal to 4.6. Okay, so I'm going to say 4.6 meters is my answer. If you put 4.56 or if you put 4.58, that would also be correct. So I'm going to say my answer here is 4.5, or I'm just going to say 4.6 meters. Okay. So what I did for this problem was I drew a sketch. I made sure to include my positives and my negatives. And I wrote down the velocities and starting positions of both of my objects. I then used that to plug in the velocities and starting positions into the general equation to make specific equations for both objects. Then I set them equal to each other, and I solved for t. That gives the time where they're going to meet. Then I plug that time back into either one of the equations to solve for position. And that's how I got my answer. Now, if you're doing something like in the lab, where you have two graphs, you should have two graphs that look like this. One should be moving up, and one should be moving down, okay? What you would have to do here is combine these two, right? So you would need to find the slope of this line, which is going to be your velocity of your first object, and the slope of this line, which gives you your velocity of your second object. Okay, and then you can use that to write your equation for each object. Okay, and you're going to be plugging in the velocity that you calculated for each. So this would be your v1, this would be your v2, and the starting position for each. So this would be your x1, this would be your x for here. Okay, and now you'll have two equations, and then you'll have to set them equal to each other. I'm not going to go through exactly how to do this because it is our quiz, but that's what you need to do. You need to find the slope of each of your lines. Then you need to use that to find the velocity, read off your graph what your starting positions are, then plug in your numbers, and then you're going to set them equal to each other and solve, just like we did in this problem. So the lab is only slightly different, and it's different because instead of drawing a sketch, we're using a graph. Okay? If you have any questions, please email me or message me through Remind. Hopefully this was helpful.